Hello, we are solving Rajasthan University's question paper, and that is the paper that we are looking at in digital electronics subject for various branches in April 2022. We have solved till part C and we have reached question number second. So C part will fetch you 10 marks, any 3 of 5 have to be done, and total 20 questions are there, but you have to do only some. Read the instructions in the section. Anyway, let us solve this question. Minimize the logic function. 4 variable function is given. Use keymap to solve this and draw a logic circuit also. So to save time, again I have put it onto a online solver so that I have all the text ready, written, available, and I can go through with the explanation. So first of all, this is the function that was given to you in the paper. Exactly that I have given to the solver, and then it came up with the keymap. So 4 variable keymap template is this. You have A, B and C, D variable listed, and these can take these values, and they are arranged in gray code, reflected code. From one code to other code, only one bit should change. So this is the template, and now we populate the template with the function. 0 is there, so A, B, C, D both or 4 will be 0. So this 1 shows that it is a part of function, and minterm 0, which is this cell, will show that. And then similarly 1 is there, 2 is there, 3 is there, subscript is the decimal number that is written, and we read these columns outside to show what the binary code is. Let us copy this and let us explain it in this place. So what I meant to say is that this part is the template of keymap, the outside part, outside of this blue line, and these A, B, C, D are the variables, and these numbers, I'm making cells, and these ones and zeros are showing that which is the part of the keymap function and which is not a part of keymap function. So this is the keymap. Now we have to simplify this. To simplify this, we have to make groups, and groups should be largest. So let us start with this one. This one has adjacent sides all zeros. Keymap can fold, and this touches with this. So the one here cannot be grouped with any other one. So this has to be taken as it is. And what does it imply? It implies 1 1 1 0. 1 1 1 0 is red for this cell, and this implies in variable form A, B, C and D complement. So this is the minterm that cannot be simplified. Let us further see what can be done. Can we simplify this function? We can simplify, and we need to simplify making largest groups. These ones are put together and they can be part of a group. Now as I told you, these two parts are touching each other in keymap, but the thing is the groups have to be in number order 2 to power k, where k is the cells. So if we go with 2 to power 0, 2 to power 1, 2 to power 2, it gives you the groups that you can make. You can have one cell, you can have 2 cells together, you can have 4 cells together, you can have 8 cells together, and so on. You cannot have numbers in between. For example, you cannot make group of 3, because group of 3 will not minimize, and this rule ensures that. Now coming back to grouping, this was the rule how to group. I have told you the rule how to group, and now let us continue grouping them. So these 4 group according to that rule. Then let us change color and find another group with the largest size. The larger the size, the best simplified function you will get, the most simplified function you will get. This is another group. Now we need to take care of these three, but these three together cannot be paired, and as this map matches we can pair this like this. These two can pair with these two. So you've got maximum number of ones and we can reuse them and we can make largest sized pairs. Again we can do another pairing can be done. We need to include this one also, and this one has got a 1 here and has got a 1 here also, 1 here also, so they can be grouped together to minimize the function. So this is another group. So these groups will give you the minimized functions. You will read them out. Let us start reading them out. Here let us go for the first step. They have gone for the same step. This cannot be simplified further and should be read as it is. Then they have got these two and they simplify to B bar C bar, because in this how do we simplify? How do we simplify from a K-map? We take the terms, we have the terms variables, and the variable that changes can be removed and that does not change has to be kept. For example, let us take one group. This is a group. In this let us find out what is the simplified result. The simplified result is A is A bar in all four, so it does not change, so you have to write it as an answer. Then B bar is also same, so this is also an answer. And what about C and D? In this C is 0 and here C is 1. So this is C bar here and C here. Similarly, here it is D and it is D bar. So these changing things can be removed, and this is the simplified form of these four minterms. So basically what basic fundamental is used. Suppose we have this is an example. Suppose we have an expression A OR with A bar. Here these minterms are separate and we are having them as OR logic in between them. We are having OR logic in between them. So here, coming back to the example, if A OR with A bar is given, it will reduce to 1. So this basic fundamental law is used to simplify this by laying them out in gray code and grouping them, and then removing the variables that change and replacing them by a 1. So 1 is making it simpler by reducing the variables, and this is the answer of this group. So continuing with the solution, what will this give us? In these four cells, this cell, this cell, this cell, this cell, B remains as B bar, so B bar is there. Then C bar is also same, so C bar is there. C bar in this cell, C bar in this cell, C bar in this cell, C bar in this cell. So in all four cells, C holds on to C bar, so it is there, and B holds on to B bar. So similarly, we can group this and solve, and at the end, when you will have all groups nicely done as I did in the solution, they have also done. So they have got this group, they have got this group, they have got this yellow group, and they have got this magenta group like this of 4s, and this red one is just 1. It has to be, it cannot be solved, it is as it is, and these are the groups, that are solved. So all the time they have taken 4 minterms in a group. For example, this blue one has got these 4 minterms, so one of them is a contribution of that, and then result of that, and one group is this green one of 4 ones. Another group will be of this yellow border. Yellow border is hidden here, but I am making it using my mouse. These two and these two. This is another one which will contributing to one of these, and this magenta will also have these two, and these two will contribute one more. So we have 4 groups of 4 minterms, reducing them to 2 variable minterms, and one has to be taken as it is because it cannot be paired. I think this is sufficient answer to this question, and now you have to draw the logic circuit of the simplified diagram. Okay, so let us draw the logic circuit also. So let us pick this up. We need to know the equation to draw this equation. So I have picked this up. I will paste it here, and this is one answer answer. What is this answer? This is that what has happened. Now let us start drawing the diagram. So diagram will have input variables as A, B, C and D, and you need to draw the logic. How will this logic diagram be made? You use symbols. So A is being ANDed with B, and then this AND gate has to be ANDed with. If you are using two input AND gates, then this will be the diagram. Okay, drawing is not clear, but since we need to do it quickly, I am doing this in this way. So this, what do we have here? Here we have A ANDed with B, and at this point we reach getting A ANDed with B ANDed with C, and here we can take a NOT gate and to get D bar, and then again we AND them together. So what is this? This is A, B, C, D bar. Note that this is simplified form, further cannot be simplified, so you have to draw all this. Now this is this, and it needs to be ORed with the other ones. So this one, this one, this one, this one will also enter here. This one, this one, this one and this one, they will enter here. And how will they be generated? I'll give you just one example. Suppose B bar, C bar is needed. So we will take this B, we make this loop that we don't touch these wires, put it into a NOT gate. So this is B bar, and similarly we take a C and put it into a NOT gate. So we get C bar here, we get B bar here, and we AND them together to get B bar, C bar, and feed it here. So what will, till now what have we got at the output? We have got A, B, C, D bar, all with B bar, C bar, and further we need to build these, and when you are done with this you will get this. I hope this helps. Thank you for this.